Mars didn't just die. It was murdered. Billions of years ago, Mars had oceans, thick skies, and perhaps even life. Then an invisible killer stripped it all away. If we want to terraform Mars, we first have to stop the killer. That means building the largest machine humanity has ever conceived. A magnetic shield in deep space, powerful enough to protect an entire planet. It sounds like science fiction, but the physics are real. Here is the blueprint for how we give a world its atmosphere back. Across Mars, dried riverbeds and empty ocean basins tell a haunting story. This world was once alive. Orbital imagery reveals a planet that was warm, wet, and remarkably similar to Earth. Liquid water flowed freely across its sweeping plains, sheltered beneath a heavy blanket of air. The fundamental question isn't whether Mars can hold an atmosphere. The question is, what catastrophic event ripped that life-sustaining blanket away? To understand the death of an entire planet, you have to look inward, deep beneath the rocky crust. Earth is protected by a churning, superheated core of liquid iron that generates a vast magnetic shield. This acts as a force field, deflecting the hazardous, highly charged particles streaming from the sun. We call this the solar wind. For our world, it washes harmlessly over the magnetosphere, much like a rushing river flowing around a smooth stone. But Mars is a much smaller world. Because of its diminished size, its internal heat bled out into the freezing vacuum of space much faster than Earth's did. Roughly 4 billion years ago, the Martian core cooled and solidified in the dark. The planetary engine seized up. The protective magnetic shield collapsed entirely. When that shield fell, Mars was left exposed to a cosmic assault. The solar wind is a billion-year sandblaster. It acts as a cosmic pressure washer, blasting the atmosphere away, molecule by molecule. Striking the fragile upper atmosphere at millions of miles per hour, this high-energy bombardment steadily knocked atmospheric gases out of orbit, carrying them off into deep space. The air pressure plummeted. The warming greenhouse effect vanished. The surface oceans boiled away, leaving behind nothing but the frozen, rusted subsurface ice we see today. Today, Mars is trapped in a state of suspended animation. Its surface pressure is barely 1% of what we feel on Earth at sea level. We can't just release greenhouse gases to warm it up, because the solar wind is still blowing. Any new atmosphere we try to build with heavy industry would simply be swept away, caught in the exact same cosmic erosion that murdered the original world. If we can't restart Mars from below, we have to protect it from above. We have one huge problem to solve before we can plant a single seed. We can't just restart the dead iron heart of Mars that is pure fantasy. So, the answer lies in orbit. We need to rethink planetary protection not as a geological process, but as an astronomical infrastructure project. We are literally talking about a cosmic umbrella, a shield stretched across an entire world, designed to cast a vast magnetic shadow, giving a dormant planet the shelter it desperately needs to finally exhale. To cast this shadow over an entire world, we have to find the perfect vantage point. If we just park a magnetic generator in a standard orbit around Mars, it will circle the planet, leaving the atmosphere exposed to the sun for half the day. The solar wind is a continuous river, so our shield must be an unwavering dam. The blueprint points us to a specific coordinate in the void of space, the Mars-Sun Lagrange point 1, or simply L1. Think of L1 as a cosmic sweet spot. It sits just over 600,000 miles directly upstream from the red planet. At this precise distance, the Sun's gravitational pull inward and the outward pull of Mars perfectly cancel each other out. It functions like the peak of a gravitational hill. An object placed exactly here stays permanently parked directly between the Sun and the planet, keeping Mars locked safely in its protective shadow. But resting on this peak is highly unstable. It's exactly like balancing a pencil on your fingertip during an earthquake. Station-keeping thrusters will have to fire constantly, making tiny, calculated shifts in weight to keep the structure from falling off the wire. At L1, we deploy the machine itself, a planetary dipole. We aren't building a physical wall out of titanium or lead. A physical barrier large enough to block the Sun's radiation would also block its sunlight, plunging Mars even deeper into an eternal ice age. Instead, we build a machine that manipulates the fabric of electromagnetism itself. The core of this megastructure isn't solid. It's a loop of superconducting wire so large it could encircle a city. It works on the exact same physics as an MRI machine in a hospital, but scaled up to the proportions of a small moon. When an electrical current gets pumped through this colossal coil, it generates a profound magnetic field. Out in deep space, the freezing vacuum becomes our greatest ally. By keeping the wire shaded behind giant sun shields, the temperature drops close to absolute zero. In that unforgiving cold, advanced materials become true superconductors. Electricity flows through them with zero resistance. Once that loop is fully charged, the current runs endlessly. The magnetic field sustains itself with hardly any extra power needed to keep it alive. But generating that initial spark and firing those station-keeping thrusters to hold the line takes a staggering amount of energy. The dipole will need sprawling arrays of high-efficiency solar panels, harvesting the Sun's own energy to build a shield against it. Or it might use a localized nuclear fusion reactor, providing the constant heartbeat needed to power the system's demands. How does this loop protect a planet a million miles away? It all comes down to the physics of deflection. The solar wind is a lethal stream of highly charged subatomic particles. When they hit a magnetic field at high speeds, they can't just fly straight through. A physical rule called the Lorentz force snatches them, forcing the particles to spiral tightly along the magnetic lines. The dipole at L1 projects a magnetic bubble that stretches far out into the dark vacuum. When the solar wind violently strikes the leading edge of this bubble, the field acts exactly like the prow of a ship cutting through rough ocean waves. The stream of lethal radiation is parted. It's forced to flow outward and around our magnetic obstacle. As the separated streams of the solar wind blow past L1, they continue outward, bypassing Mars. Behind the artificial shield, a long, calm wake forms. This region of safety envelops the red planet, bathing it in a tranquil, radiation-free void. The engineering challenges of forging this sunblocker are immense. The biggest obstacle isn't just generating the field. It's keeping the machine from tearing itself to pieces. The magnetic field exerts an outward pressure on the superconducting coil, trying to burst it open like an overinflated tire. The structural lattice holding the wire must have extreme tensile strength. We are talking about advanced carbon nanotubes, or thousands of miles of graphene tethers woven together in the dark. And we can't build this on Earth. A structure spanning hundreds of miles must be assembled in the zero-gravity environment of space, built by fleets of autonomous drones using raw materials mined straight from near-Earth asteroids. Yet, despite the scale of this blueprint, We don't have to break a single law of physics. We don't need faster than light travel. We don't need magic anti-gravity materials. We only need classical electromagnetism and orbital mechanics pushed to a civilizational scale. By mooring this magnetic dynamo at the L1 anchor point, humanity builds an artificial, external planetary core. We dramatically reduce the ceaseless cosmic erosion. We hit the pause button on the death of Mars and set the stage for the true transformation to finally begin. The instant the shield turns on, Mars stops bleeding into space. A profound, unnatural calm falls over the Martian upper atmosphere. The billion-year cosmic storm finally breaks. And protected beneath this celestial sanctuary, the planet begins a slow, magnificent awakening. Without the solar wind stripping away its outer layers, the Martian atmosphere can finally start to heal and accumulate. But the magnetic shield doesn't warm the planet on its own. It isn't forcing Mars to live. It's putting the planet in intensive care and letting nature do the rest of the work. The true transformation begins when we trigger a dormant greenhouse effect. Deep inside the Martian polar caps, vast reserves of frozen carbon dioxide have been trapped in the ice for eons. As we artificially introduce heat, perhaps by unfolding orbital mirrors to bounce concentrated sunlight directly onto the frozen poles, the surface temperature steadily rises. The white poles begin to darken. The carbon dioxide sublimates, flashing from solid ice straight into atmospheric gas. It floods the alien sky. This works exactly like rolling up the windows in a car sitting out in the blazing summer sun. As the atmosphere thickens, it traps more of the sun's ambient heat. That trapped heat melts more ice, creating a self-reinforcing feedback loop of planetary warming. As the pressure steadily climbs, the environment crosses a critical threshold. For the first time in billions of years, liquid water can pool on the surface without instantly boiling away into the cold vacuum of space. Subsurface glaciers will thaw. Rain will return to the Badlands. Ancient riverbeds will flood and carve their way through rusted canyons once again. The visual transformation of the world will be a spectacle. The dusty, salmon-colored skies will slowly fade. The atmosphere will grow heavy and dense, catching and scattering the sunlight until the red sky finally gives way to a deepening, vibrant, familiar blue. Terraforming Mars isn't about brute force. It's not about dropping nukes or running giant smokestacks. It's about extreme patience, orbital mechanics, and using the fundamental physics of the cosmos to our advantage. The engineers who build this magnetic shield will never feel the Martian wind on their faces. They will never sail on a Martian sea. It's a civilizational commitment that spans centuries. But they will be the ones who flip the switch. If humanity ever builds this machine, it will do more than save Mars. It will prove that life is no longer confined to the worlds it was born on. For 4 billion years, planets shaped life. For the first time, life would shape a planet. By building a shield across the void, we stop being just passengers in the solar system and become its architects. It's the ultimate legacy. And somewhere beneath a sky that slowly turns from red to blue, Mars would take its first breath again. If we had the technology, should we bring Mars back to life? Or leave an entire planet untouched